Good afternoon, ladies and gentlemen, about to honors. Good to have you today. You ready to be here today?
Yay.
Okay.
Hip, hip, hooray.
Hip hip hooray. Some enthusiasm. All right, I don't know if you remember a couple days ago we were working on this thing here, and then I took you on that detour for polynomial division and synthetic division. Remember that?
And then you taught us a better way.
And the reason I did that is because I got into this, I said, oh, this says synthetic division. We better, Jace, go back and work on division, right? To figure out how to do this. And so we talked about the rational zero or rational roots theorem, and we found these rational zeros out of this function here. And so what we can do is try these zeros out using synthetic division. And they used a table here already, but in synthetic division, what you can do is test the zeros. And my recommendation on these is to test the smaller numbers first, and not the fractions, because you're going to have fractions at times too. But the smallest whole numbers are usually going to be your easiest thing to start out with. And so right now we can do plus or minus 2. So I'm going to test first. I'm going to test x equals 1 as our 0. So if we test x equals 1 as a 0, what kind of factor are we testing? What is our factor related to the 0 of x equals 1?
X plus 1.
No?
X plus or minus 1?
It'll be x minus 1. Okay, so the 0 of 1 is related to the factor of x minus 1. Do you see why that's the case? You don't? Well, the reason is because if you set x minus 1 equal to 0 and solve, you're going to have x is equal to 1. So when you test this x equals 1 as a 0, you're verifying that x minus 1 is a factor. If x equals 1 works, the factor associated is going to be x minus 1. So what we're going to do is put this into factored form of this based on this. So we're using the techniques. And I had in second period I asked, well, why are we doing this? What's the point here? Well, the thing about it is it brings us back to this right here. Remember we talked about this a few days ago? How do you find the rational roots of a polynomial equation? So this is part of the process. That's all. We've done a few things since then. So here we are back here, and
I see how that chart works.
okay, what we're going to do is test the zeros. We're going to test x equals 1 as a 0. And how do we test that? Using synthetic division. 1 here, right? And what goes over here in the bracket?
Numbers on the top of the graph.
So which numbers are those going to be?
That's going to be 1, 2,
2,
19, negative 20.
negative 20. Okay, so we bring this down, 1, and that's going to be 1
Times 1.
x squared.
So you do 1 times 1.
1 times 1 is 1.
And that one, if they subtract, that would give you 1. So this would be
You add them or is it?
3.
And that would be 6.
This would be negative 16, okay.
Then negative 36.
Negative 16,
Negative 36.
negative 36, right? So is this going to work out here? No, it's not. So what we're going to do is that didn't work out, so we're going to change. We're going to go ahead and test negative 1 as a 0. So I'm going to just make some little changes here. We're going to test negative 1 as a 0. So the related factor here is going to be x plus 1. And I'm going to go change things here in the bracket because I can do that. So here we go. We'll get rid of all this. And what's going to happen when you do this on your paper, you might start running out of room a little bit. Second period did all right. So now we're going to test and bring this down. And so now what do we have here?
1.
negative 1.
Negative 1? Okay, good.
So you get 1.
and we get 1 here,
And that would give you negative 1 again.
negative 1,
So that would give you negative 20.
negative 20,
And
And then you do
20,
and that would be
0.
0. Okay, so now, is x plus 1 a factor?
Yes.
Yes, it is. So we're going to put x plus 1 right up here. And the next thing we're going to do is take, we're going to take what we have left, which is x squared plus x minus 20. Do you see where we get x squared plus x minus 20? Do you see that, where we get x squared minus x? You see where we get it? Anybody not see it? Okay, it comes exactly from right here.
What happens to the x cubed?
What happens to the x cubed? Okay, that's a good question.
Does it multiply to the x plus 1 to give you?
Right, so we divided it out, okay?
Okay.
So what is the factored form of x squared plus x minus 20? Okay, we're looking for two numbers which, when multiplied together, equal negative 20, yet when added together equal 1. What are those two numbers?
Negative 20 and positive 20. Right?
Nope. It's going to be a positive and a negative.
5 and negative 4.
Positive 5 and negative 4? Okay, let's try this. We're going to try, Steve-O says x plus 5, and he tries x minus 4. Is that right?
Yeah.
Is that going to work out?
No.
Yeah, it is. So we know that our factored form is going to be x plus 5 times x minus 4. And that's the fully factored form. And so that is going to be our answer to the question. Okay, is this making a little bit of sense?
Yeah. Well, how would you do it if you did it with 2 instead of the 1? Like, would it turn out?
Yeah, if you tried 2, now 2 isn't going to be a 0 of this thing. So what we would get is we would get another non-zero remainder if we tried 2.
Well, then why does she say use the factor of negative 20? 1 then says 2, so why 0?
Well, what it is, you only have, here's your list of potential zeros. Okay, how many do we have on this list? 1, 2, 4, 6, 8, 10. We have 12 possibilities. We have 12 candidates, but we only have a maximum possible actual use of 3 of them. Okay? So most of those are going to be, 9 of those 12 are not even used. Right? So it doesn't mean you use all of them, it means that these are candidates.
X minus 4 is also 1 because 4 is a 0.
Yeah, so 4, so that's a good point. Okay, so Brian says 4. What we can do, if we take 4 over here and put 1, 2, negative 19, and negative 20, we should come out with a 0 here, right? Well, we do that, we get 1, 4 times 1 is 4, 6. 6 times 4 is 24. This is going to be 5. 4 times 5 is 20. 0. So now we have x squared plus 6x plus 5. And we could factor this out to be x plus 1, x plus 5. Right? Which we have that. So it doesn't matter which one you do first in the order of the factoring, does it?
But then the 4 will be positive. Because you use a positive 4.
Yeah, well, it'll be, the factor is x minus 4, okay?
Then
So here's the factor is x minus 4, which is related to the 0 being 4.
And you can see how they go together because that's x plus 5 is moved
Right.
over there.
So you all make good observations here. Now, I'm not going to work this next one out because it's the 4th power, but I will show you something. And then we're going to go to the exercises. Okay. Well, here, okay, that's how they said it here. Okay, now if you have an x to the 4th power one here, you can try working this out. And by the way, what happens is, I will tell you in advance, since it's a 4th power one of the zeros I believe is 4. So if we take 4, we take x to the 4th power minus 4x to the 3rd power minus 7x squared plus 22x plus 24, and we work this out. We get 1, 4 times 1 is 4, 0, 4 times 0, 0, negative 7, and we get this negative 28,
Yes.
and we get negative 6, and we get negative 24, so 0, and so x minus 4 is one of the factors. And then we can continue going on and do the rest of it. But I don't want to do that. I want to go to our exercise, okay?
It would be, the factors would be 1, 2, 3, 4, 6, 8, 12, and 20.
So here's your factor analysis here, Victoria, right? X minus 4, so we solve for x, we get x equals 4. Okay, so it's an additive inverse type relationship between the value of the 0 and how it looks like when it's put in the factored form. And people, that's a very good thing. That's kind of a confusing principle of it. But if we're going to go ahead and graph, for example, the function y equals x minus 4, what is that going to look like? Well, here's what it's going to look like. We go here, and we have our y-intercept of negative 4, but where does the function cross the x-axis? At x equals 4. So the function is y equals x minus 4, but the x-intercept related to the function y equals x minus 4 crosses the x-axis at x equals 4. Okay, so this is one thing that really takes some time and some thinking and some experience kind of getting used to, because it really is not super intuitive, is it? It's sort of like when you're translating a function left and right. X plus moves to the left, x minus to the right. Yeah, that's the same sort of thing. Okay, but those are some good questions and observations. I appreciate that. It's one thing I can usually count on for this classroom is good questions and observations.
Well, we only have 2 1 12.
Say it's my room. I'm trying to help you out.
I have a boxer and a.
The boxer show?
Yeah, one of those. I have a boxer and a regular. Yeah.
Okay, here we are on this thing.
I didn't get one. Oh, yeah. I know what it's done.
Yeah, okay, we're good. Okay, let's get to this exercise set, which is right here. And yeah, I'm going to leave 2 just like that. Okay, here, I'm going to get a skinny pen here. Okay, find the rational zeros of each polynomial function, then write each function in factor form. So what I'm going to do is just sort of use problem number 1 as an example, worked out example. How's that? Are you okay with that? Okay. So the possible rational roots, I'm going to put possible rational roots. roots. What are they going to be? They're going to be factors of 8
So we're going
plus or minus factors of 8. So that's going to be, what are your factors of 8?
plus or minus 2,
2,
plus or minus 4,
plus or minus 4.
plus or minus 5.
No. Plus or minus 1, plus or minus 8. So those are your possibilities. And it's going to be over the factors of the first coefficient of leading term, which is 1. So really your list of potential rational zeros ends up being this. And my recommendation is, unless you have some kind of insight, is to work with the smaller numbers first. Why the smaller numbers first?
Because they're easier.
Because they're easy.
Yeah, the arithmetic is usually a little easier.
And you don't need a calculator.
You don't need a calculator as much. But you shouldn't need a calculator for any of these, really. So anyway, we're going to first try x equals 1 as your 0, which is the same as the factor of what? X minus 1. So we are with this going to test to see if this 0 is a good 0. If it is, then we can use that as a factor. So here we're going to put the 1 out here, and then 1x cubed minus x squared minus 10x and minus 8. All right? Then bring down the 1. 1 times 1 is 1. 0, 0, negative 10,
Negative 18.
and negative 10, negative 18. So is x equals 1 a 0? No, it is not. So it does not work. And sometimes, just to keep track, you can just sort of cross through it if you want to, which I'm going to do. So we've kind of checked that one off the list, right? Now we're going to try.
The next one.
We're going to try x equals negative 1, which is related to a factor of
X plus 1.
x plus 1.
Right.
So we go here and say, all right, same sort of process, negative 1, 1, negative 1, negative 10, negative 8. So we bring this down here, and negative 1 times 1 is negative 1. We get negative 2 here, and we get negative 1 times negative 2 is 2. Negative 10 plus 2 is negative 8. And negative 1 times negative 8 is 8.
It works.
So we get 0. So that means that is a factor. So I'm just going to write part of my answer up here as x plus 1. We know that's good, right? That's a good factor. And so what do we have left here? Well, we have x squared minus 2x
Minus 8.
minus 8. And what is the factored form of this thing? We know it's x and x.
You have to add up to what? And or multiply to what? Negative 8? Or which one?
What's going to be the factored form of this?
Negative 4 and 2.
Brian says negative 4 and 2, so let's try x minus 4 and x plus 2. Does that look good? Because we multiply these back together, we get negative 4x, and we get 2x, which add up to be negative 2x. That looks good to me. So now we can fully write our answer, can't we?
Is there?
So you have x minus 4 here, and then x plus 2. But it's what Brian did is the answer to the question, what two numbers which when multiplied together equal negative 8, yet when added together equal negative 2. All right? Good work. Now, what I want you to do is to work on, is go start to work on problem 2. Now, I will tell you that I'm giving you a little head start, because what do you notice about 60?
It's 50.
Look at all these potential rational zeros. I put a rational zeros list on this thing, right?
Wait, why is 1 and 2 crossed out?
He says they're wrong.
Yeah, I'm saying they're wrong. And what I'm doing is I'm letting you start with plus or minus 3. You see what I'm saying? So I want you to work on number 2, and then I'll choose somebody, we'll go over it a bit, okay?
On number 1, how did you get the x squared minus 2x plus 8?
Okay, I'll show you where that comes from. It comes from the result of your synthetic division. It's right down here. Here's your x squared. This is x squared minus 2x minus 8. That's where that comes from. Okay, that's an excellent question. So I'm going to give Riley some credit for an excellent question and Brian some credit for factoring, all right?
I think it's a pencil. Get on myself.
You can write all those factors down.
Can you what?
Can we just look up there, do you want us to write all the factors down? So,
Oh, yeah, you can, I don't know.
Is it any point?
Yeah, there's not a lot of space here, so you can use some extra paper. What happens is, a lot of my students, what they'll do for these things is they'll really get like engineers and write really small.
So is it any of the numbers at the bottom that you can use, or so no, like the factors? If there's any of these numbers, or which one?
It's not these, you get them from a list of factors. Then you can get
Just write it?
This is where they come from, right here. So start with 3, then if that doesn't work, go to negative 3.
How do you know? It's time, like, when they work.
She has to do it. Yeah, we'll write it, we'll really write it properly.
Okay. You need a couple more minutes? Okay, you still working on it? We'll check out something, I'll be right back. Spinning.
Don't be 20 or 26. I'm writing that before. Does that say 20 or 26? I'm which one?
I'm scared because
Yes. Okay, so what, let me ask it again. This part here. Yeah, you take, yeah, the one, it's that one here, plus 1, so you're using it. And once that doesn't work, you check it off the list, and you try negative. That's right, use plus and minus 3 first, I'm telling you, it's not 1 or 2. So what I'm doing, by crossing off plus or minus 1, plus or minus 2, I'm saving you a lot of work, because I'm just telling you those aren't right.
what was this one? Which one, right?
The ones that are crossed out in red.
Oh, okay.
So I'm giving you a little head start on that one. Because all these factors of 60.
Can't you just like guess, pick one up and then?
Yeah, you can guess one. If you have some
Yeah, you're
intuition about what they are, yeah, you could do that. I like to go down the list from the least to the greatest, but you can just pick them out too, yeah. If there's some indication or intuition you have that one of the other ones might be right, you could try it first.
Yeah.
But then you have to be
This is my
careful.
lucky number, so I'm trying it.
Yeah, that may work, may work. I just like the regularity of starting with the smallest, going up.
Yeah, that makes sense.
So that's,
-3 would be x plus 3.
I'm hearing some people are coming around to getting an answer on this already.
Whoa.
Yeah, and really when you think about this whole thing we're doing here is sort of a big, you have an answer? When you think about it, what we're doing here is a process of a lot of different things, isn't it?
Yes.
And so you get one place and so, okay, we got that, what next? Yes, Luke, you have a question?
I just have a question. Did you go to Sterling High School?
Do I?
Did you like? When you were in high school?
No, I didn't attend. I attended high school out in California.
Oh.
Yeah. So I was in
What?
Santa Clara. Do you know where the 49ers play? In Levi Stadium? That's the city I grew up in.
I grew up in a place called Allen,
So like if I,
California.
like this.
Yeah, you told me.
is
40
like
minutes
the
away
x
from
squared
Fresno.
minus
Yeah,
two
the foothills
minus
kinda?
x
Yeah, what
x
hills.
squared minus 1 minus
Yeah.
2. Yeah. Is
Yeah, I remember always check the answer. Just kind of function, take it out there.
To graph them? Yeah. Yeah, that's right. Graphing them is how you can check your work. But what we're trying to do is build our analysis skills without using the calculator. No, that's a good way to do it. Okay, good.
So this would be.
We've had some good, I'm hearing some good conversation here, which is really good. Makes me happy you guys are learning things. Christian,
Squared minus
Mr.
1
Allen.
minus 1.
what did you do, Christian? What did you do?
You put some arrows.
Show me what you did. Which one did you try first?
15, but I think I'm doing this wrong.
20 is in the
But I can tell you what I did, but I don't think it's right.
Okay, here, I want you to, here, Christian, I want you to work with me, Christian. Here, what did you try first?
I'll put that, I don't even know what to call that. But the thing you taught us yesterday,
Which one did you try first?
15, positive 15.
Try 15, okay. So we're going to try 15.
I don't know what you're asking.
So if we try 15, we're going to have, what numbers go in here?
Would it be 1, right? 2, 23, or negative 23, and negative 60, right?
Yeah,
And then you bring down the 1,
1,
and then you multiply that, so that'd be 15. And then 17.
17.
You multiply 15 times 17.
Those numbers get pretty high there, right?
Yeah, they get high. That's why I was like, iffy about it. Just 255.
255, okay. I'll just put 255. So we get 255. And when you see numbers this big, and then you multiply these together,
Mr. G.
you know the thing's getting way out of control. So
Yeah.
you know that that's just not feasible. So you can,
Down.
so you cross 15 off the list, right?
Yeah, and then I'm assuming the other ones are wrong too.
So which one do you want to try next?
240.
I guess we're gonna do 4 now.
4?
Negative 3.
Negative 3, okay, we'll try negative 3. And so we put 1, 2, negative 23, negative 60.
Sir.
But, okay, Chris tried this 15, it didn't work out. Was he permanently scarred for life because he did that?
Yeah.
Well, I am. It like exhausted my brain just doing that.
No, the serious answer to my question is, no, it is not. So there's no
Keep
harm.
trying.
Yeah, there's no harm in trying something that doesn't work out, okay? So it didn't work out. Next.
Down to 1. Negative 3.
So 1, negative 3 here, Chris, is that right?
Negative
negative
-1.
negative 1, and then 3 here,
Yes, sir.
and add these together, what do we get?
-20.
Negative 20, and then we get,
What is this? 80? Oh, did I do that? Or 60, my bad. I'm wrong.
60, 0. So is x, is minus 3 a 0? So what is one of the factors here? What is a factor? What is a factor related to the 0 of x minus 3? Of x equals negative 3, excuse me. Well, it's x plus 3. Okay, so we know that x plus 3 is one of our factors. What do we have left over, Chris? We have x squared minus x minus 20. What's our factored form, Chris, of x squared minus x minus 20?
X minus 5 and x minus 4, right? Or plus 4, my bad.
X minus 5, x plus 4. Does that work out?
Yeah.
Yeah, it does, okay. So now is this fully factored here?
Yeah.
And actually, hang on a second, it's not this one here, it's this over here, right?
Took forever.
So that doesn't equal that over there, it's over here. So, and then just as a quick check, you can multiply these 3 times negative 5 times 4, you should get negative 60, right? Which you do. All right, Chris, see? Good, good job. See, he's willing to work through this a little bit, and we're good, right? All right, what I want you to do on this next one,
Did you almost the other thing?
okay, over here,
Stupid, stop cheating.
now this one here, on number 3, before, well, I guess you're already starting to work on it. What are your potential rational zeros here for number 3?
Is it plus or minus 1, plus or minus 2, and then 3 and 6? Is there only 4, or is there more?
There's actually more, but we'll figure these out.
Okay.
We're still working on it.
Now, if you look at all these problems, most of these problems here look like it's just like 1x cubed, blah, 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 right? Well, here they give you 2x cubed. And so what you're going to have your possible rational zeros are going to be plus or minus your factors of 6, which are, as Victoria says, 1, 2, 3, 6, over the factors of 2. What are your factors of 2? 1 and 2. So what it is, you have 1 over all these are going to be your possible factors. So you get plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Where do other factors, potential factors, come from?
Division.
Yeah, 1 over 2. So you can get plus or minus 1/2. And then you try 2 over 2, which is 1. Then you have 3 over 2.
Which is 1.5.
It's 3 over 2. It should be 3 over 2. Okay, plus or minus 3 over 2. And then 6 over 2, that's 3. So yes, we have more potential rational zeros here. Okay, I got like people here that are...
Just take all that, dude.
Everyone asked if we made this. They get worried.
What is it, banana bread? Oh, I made those, Mr. G. Mr. G, I made those.
You made them?
Yeah, I
Pick
helped.
everyone up that comes in.
I actually helped Mr. G. Banana bread.
Oh, they smell good, you guys.
You're welcome, Mr. G.
I checked my weight on the scale last night. It was up a little bit, but that's okay. Not up, not drastically so.
Let's go on a, oh, you gotta get ready for the race, Mr. G. You gotta lose all that weight.
But I got several months to go though.
You gotta start now.
And I don't need to lose that
He's the
much.
top of the top.
Okay, so now, let's try our zeros. So you're trying them, I'll pick somebody, okay? So you're working it out, we gave this, and this was Victoria's question. All right, Victoria, I'll give you credit too, Victoria.
Shoot, Mr. G, can you please? Okay.
First one,
Send me a picture of your face. So I'm gonna just like put it on. And then,
We're running a little bit low on class time, so let's see if we can finish this one up. And tomorrow, we're probably not going to have a regular class because second period is not going to have regular, so we're going to be in sync. So we might play some Kahoot games based on this tomorrow. But anyway, let's go figure out, let's quick go over this with one person we choose here, which is going to be Jace or Brian. Jace or Brian. It's going to be Brian.
What are you gonna do?
All right, Brian, what do we got?
the rest of it.
Well, what did you do first?
No.
Did you test, zero did you test?
The first one I tested was x minus 2.
Did that work?
Don't do
No.
it.
What worked?
He destroyed my
X plus
flower.
2.
So 2, like this?
No.
Oh, minus 2. Okay, so you tested this one here, so let's go ahead and do this quick because we're out of time pretty quick. So negative 13, negative 6, right? So we bring this down, so we get 2, and we get negative 4, and then this is going to be negative 5, is that right? And then negative 2 times that, it's going to be 10,
And so I would give you 3,
negative 3,
which would give you
6, 0. Okay, so what we have so far is x plus 2, right? Out of this, right? Okay, now we're going to have 2x squared minus 5x minus 3. What are the factors of that?
I forgot how to do these ones.
Okay, so let's go ahead and do that quickly here. So we're going to have AC up here, which is negative 6, and B down here, which is negative 5. So which two numbers, which multiply together equal negative 6, add together equal negative 5?
Negative 3, negative 2. Negative 3 and 2.
No, because negative 3 and 2 aren't going to give you this added up. Negative 3 and negative 2 would, but you won't get negative. You got to have a negative number and a positive number. So two numbers, a negative and a positive, are going to equal negative 5. I'll make it easier, okay? It's going to be negative 6 and positive 1, yes. Then we divide by a, and a being 2. So we have negative 3 here. So we're going to have x minus 3, and then we have x, so x minus 3, and then so we have x equals 1/2, or x plus 1/2. And what is this going to be bottoms up? 2x plus 1. So here's 2x plus 1, and that's 2x plus 1 up here. So that is our answer. So that is it. Let's see if we can get our desks wiped. I'll just wipe your desk. Yeah, I'll wipe them down.
I'll be there. And then I'll be. You won't be there.
Well, I can't be there.